Hi guys, welcome back to my YouTube channel Open Green Energy. In this video I will show you how to make two different types of power supply. Power supply is very important device for every maker. If you want to make electronics project, then power supply is very important for you. Guys, I hope this video will be useful for you. So without any further delay, let's move to make the project.
To make this project, you will need XL4015 buck converter module, a LED volt ampere display unit, two 10 kilo ohm precision potentiometer, two winding post, two rocker switch, fuse and fuse holder. In the beginning, you have to remove the two on-board trim ports. Here I am using a desoldering pump to desolder the trim port from the board. Now we will solder the two 10K precision potentiometer in place of the trim port. To solder the external potentiometer, I am using 24 AWG wires. First I strip out the insulation by using a wire stripper, then I solder it into the XL4015. During soldering the terminal wires to the potentiometer, be sure you are connecting to the right pin. Apply small amount of flux at the terminals before soldering.
This video is sponsored by PCBWay. You can order high quality PCB for your prototyping from PCBWay. You can order 5 PCB at only $5.
The entire circuit is based on XL4015 buck converter module. The input terminal of the buck converter module is connected to a DC jack through a fuse. You can give 5 to 36 volt DC at the input. The fuse is used to protect the entire circuit. Come to the output section. The output terminal of the buck converter module is connected to the binding post through a rocker switch. You can adjust the output voltage and current by using this on-board trim port. But for precise adjustment of the output voltage and current, here I have used two 10 kilo ohm precision potentiometer. A volt ampere display is used to display the output voltage and current. The power supply required for the display unit is taken from the input side through a rocker switch. This is the voltage sense wire. The thick black and red wire is for carrying the output current. You can see the specification of XL4015 buck converter module. The input voltage can be 5 to 36 volt DC. The output voltage is from 1.25 volt to 32 volt DC and output current is from 0 to 5 ampere. The maximum power handling capability of this board is 75 watt. If you want to use this board for 75 watt continuously, then I will highly recommend to use an external cooling fan. You can download the schematic from the link given in video description. Now you can make the circuit by following the schematic diagram. To make the enclosure for this project, I downloaded the design from Thingiverse. Then I customized it on OpenSCAD and Fusion 360. Then I print out the design by using my Creality CR10 3D printer. You can download the .stl file for this enclosure from Thingiverse. The link is given in video description. I have also printed out the two knobs for the potentiometer. Finally, I highlighted the text and symbol on the front and back panel with a permanent marker. After making the complete circuit, you have to connect the wires to the input and output terminals of the XL4015 module. Be sure the polarity is correct. To dissipate the heat generated from the XL4015 IC, I have attached an external heatsink. Now you can mount the buck converter module on the bottom part of the enclosure. After installing the buck converter module, you have to mount the front and back panel. Then cover the top enclosure part. At last you have to secure the enclosure by 4 screws. Insert the 3D printed knobs into the potentiometer shaft. Now the power supply is ready for use.
The kit contains a nice PCB. The components are not properly segregated. So initially I segregate into different categories like resistor, capacitor. Then I measure the resistance value by using my multimeter. Then place it separately. In the PCB you can see all the components are named perfectly. So you can place the component according to the name and their values. Then I start my assembling process by soldering the components. I always start with the components which have smaller heights like resistor, diode, then capacitor, then so on. After placing all the resistors, I solder them. Then I trim the legs by using a nipper. Before soldering the bridge diode, you have to bend the leg with the help of a nose plier.
I use some heatsink compound to the metal part of the power transistor. Then I screwed it into the heatsink. Similarly, I apply heatsink compound to the other transistor. Then I attach to the heatsink. After soldering the transistor, I mount the DC fan with the heatsink. Before soldering the JST connector to the potentiometer, I inserted some heatsink tube. Then I solder the connecting wires to the potentiometer and I use a lighter to shrink the tube. The enclosure is based on the Thingiverse design Ultimate Box Maker. The front and back panel is modified on Autodesk Fusion 360. Then I print the enclosure by using my Creality CR10 3D printer. I mount the USB socket by using some hot glue. I installed all the other components to their corresponding holes on the front panel. I place the PCB on the PCB feeds on the bottom cell. Then I mount it by using 4 screws at the corners. Similarly, I place the transformer on the base. Then I screw it by using some washers. After installing all the components on the enclosure, I wire all the components according to the wiring diagram. I connect the PCB output to the front panel as shown in the wiring diagram. After completion of my wiring, I close the front and back panel, then cover the top cell. Now see the wiring diagram. Power coming from the AC mains go to the transformer. Then it is stepped down to 24 volt AC, which is connected to the PCB input. This 24 volt AC is rectified by using this 4 diode. Then the rectified DC contain lot of ripples which can be removed by this smoothing capacitor. This DC voltage is not regulated. This can be regulated by using a regulation circuit. Then the voltage and current can be changed by using this two potentiometer. The 24 volt DC supply is stepped down by this buck converter unit. Then the potentiometer is set to give the output of 5 volt, which is connected to the USB terminal. The power output from the PCB goes to this rocker switch, then goes to the display unit, then goes to the binding post for connecting the external load. I desolder the LED on the PCB, then connect wires to a external LED on the front panel. Now we can to test the power supply unit. I have to first plug in my AC mains. Then switch on the power switch. You can see the LED is glowing, and you can also hear the fan sound inside the enclosure. As well as on the front panel, you can see the voltmeter display is also working. To check the voltage reading, you can turn on the voltage potentiometer. You can see the voltage is gradually increasing. If you turn the voltage knob to the maximum position, the voltage is around 31.8 volt. To check the current reading, I have to connect a external load. For external load, I am using a lead acid battery. First, plug in the banana plug. Now connect these wires to the battery terminal. Be sure the polarity is perfect. First, set the charging voltage. Set it to around 13.5 volt. Yes, it's okay, 13.6 volt. Now I have to set the charging current. Slowly turn on the current knob. Yes, the current reading is now showing. It's around, it's too much high. Yes, it's 0.72 ampere. It is pretty perfect for this 7.2 ampere hour lead acid battery. To confirm the current reading, I am going to use my clamp meter to check it. You can see the clamp meter reading is 0.72 ampere, and on the power supply unit this is also 0.72. That means my power supply unit is working perfectly.
Guys, I hope you have enjoyed this video. If you like this video, then don't forget to share it. Please subscribe my YouTube channel by hitting the subscribe button, and don't forget to hit the bell icon so that you will get notified whenever I upload a new video. Thank you. Have a nice day.